All right, so today's topic is solving right-angled triangles. And our goal is to use the three primary trig ratios, Pythagorean theorem, and the sum of the angles in a triangle to solve for all unknowns in a right triangle. So when we're asked to solve a triangle, that means find all of the unknowns in that triangle. Usually this requires you to find one piece of information by using trig and all others some other way. Although you can always use trig to find those other unknowns as well. So the tools that we could use here are our trig ratios. So we can use SOHCAHTOA. We could use Pythagorean theorem. So if we know two of the sides, we can use Pythagorean theorem to find the third side. And the sum of angles in a triangle is always equal to 180 degrees. So if at any point we know two of the angles, we can just subtract them from 180 to figure out the third angle. So in example 1 here, we know this angle in the corner here is 90-degree angle. We know this angle here is 23, and we know this bottom side is 32. Now, so right at this point, I don't know side Y, opposite angle Y. I don't know side Z, opposite angle Z. I know side X. This is side X. I know that X is 32. But really, what I have to find here are those two sides, Z and Y, and I have to find angle X up in the top there. So I'll just put theta there. So actually the first thing I'm going to do here, the easiest thing to do is when I know two angles, I can easily find the third angle. So angle X equals 180, subtract 90, subtract 23. So angle X is equal to 67 degrees. And I'll just put a circle or a box around that to show that that's one of the unknowns. So I've got angle X. Now I need to find side Z or side Y. And the nice thing with trigonometry is that we could find either one. I'm going to find Z first, but we could find either one. So if I'm going to find side Z, I'm going to use this angle here, the 23. And now if I'm going to use trigonometry, I've got to label the two sides I'm going to work with. So I'm trying to find this angle, that's opposite. And the side that I know is 32. So if I look at SOHCAHTOA, O and A means that I'm going to use tan equals opposite over adjacent. And then I'll substitute in what I know. So I know the angle. Remember, the angle goes in where the theta is in the formula. The opposite side is side Z, and the adjacent side is 32. So to solve for Z, I'm going to do 32 times tan 23. So on my calculator, I'm going to go, let me just add in degrees, that's good. I'm going to do 32 times tan 23, enter, and I get 13.6 if I round it to one decimal place. So Z equals 13.6 for that. And that's centimeters because the 32 is in centimeters. Okay, and then to find y, I didn't do a very good job of using the space here, but to find y, I could use trigonometry. I could also use Pythagorean theorem. So c squared equals a squared plus b squared. So y squared, y is the hypotenuse, and then 13.6 squared plus 32 squared. So at the end, I end up taking the square root of 1208.96. So y is equal to 34.8 centimeters. And as we've said, it's always a good idea to check and make sure that makes sense. Y should be the longest side in the triangle, so 34.8 makes sense to be side Y. All right, in the second example here, we've got a right angle triangle. We're given a 90-degree angle for this triangle. So if I draw a right angle triangle here, here's a triangle, and we'll substitute our stuff in. So we know that angle L is 90, so this is the L here. Side M is the biggest side, so if this is the biggest side here, 12, then this will be angle M here and angle N at the top. Okay? And then to solve this triangle, you can see that in this case, we've got that, we've got that. Oh, we also know that side N is 4, so that's going to be 4 there. This time we know two sides, and we don't know any of the angles except for the 90. Okay? So, first thing we're going to do in this case is I'm going to find angle, whoops, my angle sign backwards here. So I'm going to find angle M. So if this is the angle that I'm working with, the 12 side is opposite, the 4 is adjacent, so I'm going to use tan again. So it's going to be tan theta. This time I don't know the angle, but I'm going to get 12 over 4 as my fraction. So remember, when we're finding the angle, when the tan goes to the other side, it changes to tan inverse. When I do tan inverse of 12 over 4, I get 71.6 degrees. And actually that, I can put angle M here because that's really what I'm finding is angle M. Once I know angle M, then I can find angle N, because angle N is going to be 180 minus 90 minus 71.6. So angle N is equal to 18.4 degrees. So I've got these two angles. I need to find this side here, which is side L. I'm going to find L. That again. I'm going to try and find L. And when I'm finding L, I can use Pythagorean theorem for this. C squared equals A squared plus B squared. So when I square those and add them together, I'm going to get 160. So to find L, I need to take the square root of 160. So L is equal to 12.6 units. Check to make sure that makes sense. It's longer than the other two sides, so that's a reasonable answer there. All right, last example here. So the tangent ratio for angle A is 4/7, and angle B is the right angle. So this is some odd information we have here. So let's plug in our information here. So angle B is the right angle. Okay, so the tan of angle A is equal to 4/7. That's what we've got in this information here. That means that side 4 is opposite angle A, and side 7 is adjacent or beside angle A. So if that's 7, that's where the A would go, and this is where the 4 would go. So we've got that information in there. Let's find angle A to start with. We already know that tan A equals 4/7. So A is going to be tan inverse of 4/7. So angle A ends up equaling 29.7 degrees. And just be aware when you're doing questions, sometimes they'll ask you to round it to the nearest whole number, sometimes they'll ask you to round it to one decimal place, so you just want to be careful of that. Once I know angle A, then I can find angle C. So angle C is going to equal 180, subtract 90, subtract 29.7. So angle C is equal to 60.3 degrees. And then our last one, we want to find side B. I'm actually going to call it X here, because if I'm going to use Pythagorean theorem, I'm going to get confused with the A, B, and C. So here I'm going to find side B. But remember, I'm going to use X when I plug things in. Whoops, not yet. Go down. So I'll write down that. And remember that the side we're finding is actually side C, as in the hypotenuse of the triangle. So that's going to be x squared equals 7 squared plus 4 squared. So we end up with the square root of 65. So x is equal to 8.1, and that makes sense of the question. So we are good to go. So we've got some questions we'll practice tomorrow in class. Thanks very much.